class. All right, so today we're going to be looking at Tuesday's work. So here's our slideshow presentation, and we'll be moving it on. Make sure you're completing this day by day. Please don't try to rush it. Don't try and mix the customary and the metric systems. All right, so make sure you are completing it on time and give yourself enough time for feedback. Yesterday we talked about the metric system. Today we're going to continue on the metric system. So today we are on Tuesday, day 2. Now this is where your video would be. I'm recording it, so that's why it's not there. And this is what we will be completing in just a few minutes. So let me go to my worksheet. Give it a little bit of weight. Kind of stand here. Okay. Now, if you have your paper from yesterday, this is why I said to save it, to kind of hold all your answers right here, and then you've got Tuesdays over here that I've already labeled off. So today we're going to continue on what we did yesterday. Now let's read some of these questions. This says, number 1 says, which of the following would most likely have a mass of 1 gram? Now let's think about what a gram is. Now remember I showed you that this is 1 gram, weighs hardly anything. Maybe like if you think about like one single grape, it would weigh like a grape. Which of the following would most likely have a mass of 1 gram? Okay, well think about a box of marbles. Now marbles are solid and, you know, obviously more than one in there. They're going to be a little bit heavy, so I don't think that that's my answer. A large dog, well, I'll tell you what, even a small dog would not weigh a gram. No way. So large dog, definitely not. A paper clip. Now that's a big possibility. I would say so. And if you look back at our picture, paper clips are about a gram. Now a can of soup. Oh goodness. Now a can of soup is fairly heavy. It is not light by any means. So that is a definite no. And my answer would be C. Okay, let's move on to the next one. So use the table to answer questions 2 to 3. The conversion table shows the equivalent metric measures of mass. So 1 kilogram is 1,000, 2 is 2,000, 2 kilograms is 2,000, 4 kilograms is 4,000. So the question says, a female tiger at the Fort Worth Zoo has a mass of 84 kilograms. What is the mass in grams of the tiger? Well, it's kind of like continuing this table. Remember we did in and out tables, where if I know the kilograms, well, I would put 84 here. Now I know my process right here between these two numbers is times 1,000. 1 times 1,000, 2 times 1,000, 4 times 1,000. So 84 times 1,000 would equal to 84,000. And now I'd use my little trick, underline my basic fact, which is 84 times 1, and dot my zeros. And the dots tell me how many zeros I should have, 3 zeros. Okay, so a female tiger at the Fort Worth Zoo has a mass of 84 kilograms. What's the mass in grams of the tiger? Well, if I look at this answer, this does not match. In fact, there is one too many zeros right here. They multiplied this by 10,000. Not right. 8,400, well, no, they multiplied that by 100, and we should have multiplied by 1,000. Now this matches our answer, so that looks like it's right. And this answer was multiplied by 10. Okay. What is the relationship between the number of kilograms and the number of grams? Well, I know that 1 kilogram equals to 1,000 grams, which means that that 1 gram is 1/1,000th of a kilogram. So this says the number of grams is 1/10 the number of kilograms. Well, that's not true because we just said that the relationship is 1 gram is 1/1000th of a kilogram. So that's not right. The number of kilograms is 100 times the number of grams. Again, no, because we're not multiplying 1 gram times 100. We're multiplying 1 times 1,000, not 100. Okay, the number of kilograms is 1/2 the number of grams. Let's think about that. I don't think so. The number of kilograms is half the number of grams. So that's like saying 500 grams sounds strange, and we don't use halves with the metric system like that. Okay, the number of grams is 1,000 times the number of kilograms. Absolutely, and that's exactly what we said earlier. Okay, 4. Allison created this table to show the relationship between metric measurements for length. So 1 meter equals to 100 centimeters, 2 meters, 200 centimeters, 4 meters equals to 400. So remember, our process, it's still an in and out table where we are doing our process, so it's times 100, times 100, times 100. Allison wants to extend the table to show equivalent measures of 6, 10, and 25 meters. Which of the following shows the correct conversions for these lengths? So this is just saying, if I continued this and I put 6, 10, and 25. Now remember, our process is times 100. So I look at F, and what they've done here is, well, 6 times 10 is 60, they're not doing times 100, they're doing times 10 here. So the rule that they're using is times 10. Do we want times 10? No, because our process right here is times 100. So F is wrong. Now we look at G, and 6 times 100 would be 600. And this they are multiplying times 1,000, which is also incorrect. Now let's look at H. Well, this looks correct. 6 times 100 is 600. 10 times 100 is 1,000. Oh, but let's look at this. 25 times 100 is not 25,000. This one right here is wrong. So these two are right, but this is wrong. Now let's look at these. 6 times 100 is 600. 10 times 100 is 1,000. And 25 times 100 is 2,500. This would be correct. Now let's look at this last one right here. Which of the following shows the relative sizes of 1 centimeter and 1 meter? Now let's think about what 1 centimeter is, because 1 centimeter is really very tiny. Remember I said it's about the width of a pinky. So centimeter is about a width of a pinky, and meter is from the floor, maybe all the way up to our waist. It's about the floor to a doorknob. So that's about how long it is. So let's think about those. A says the width of a fingernail and the distance from a doorknob to the door. Well, that's just what we said. Let's put a question mark. The length of a new crayon and the length of an unsharpened pencil. Well, a new crayon would be about this big. That is way bigger than a centimeter. And a pencil would be a lot longer. I mean, this is my pen, and this would be just about as long. There's no way. The height of a baby and the height of an adult. I don't think the height of a baby is this small. And I don't think an adult would be a meter, probably a little bigger than that. The length of a little finger, so the length of a little finger Well, that's a little bit too long right here. And the length of a football field. No, that's way too long for a meter. So our answer is A. Now make sure that you are jotting down your answers on your little handy dandy nifty sheet right here. So that way we can just copy them on to our computer. Now what I've done is I have gone ahead and I've made it look this way, so that way all you need to do is take this little dot. Let me exit out of this. Take this little dot and drag it over to our answer. So we said that our answer was C, and you're just going to kind of cover that C up right there. Now, if you want to, you can make this a different color simply by just hitting this little highlight and making it a different color if you want to. You don't have to spend too much time on it, but you're just going to drag these over to their correct answers. So these are movable. You'll go to the next page and you're going to do the same thing for these, and you're just going to put it in its correct spot, and that's it.